Welcome back to the lab, folks. So we're going to take another look at the 555 today. Now, it's been around a long time. Everybody's kind of familiar with it, and I'm sure you've all seen a block diagram like this of the 555. We're going to briefly look at that, and then we're going to have our partners over at PCBWay help us out with this one. They're going to sponsor this. They're going to provide some circuit boards. We're going to build a 555. So let's see how we're going to do that. So if you look at the block diagram of the 555, we've got a voltage divider. Now, in the actual 555, the resistors in the voltage divider are 5K, 5K, 5K. Some people say that's where the term 555 came from. I don't know if that's true, but it's a good story. So yeah, we'll go with that. And so that gives us our VCC, whatever that might be, and 2/3 VCC and 1/3 VCC, which go into this pair of comparators here. One set up to trigger on a voltage going below 1/3 VCC. The other one is set to respond to a threshold going above 2/3 VCC. And of course, we have this control voltage here, which will allow us to adjust those voltages from their standard 2/3 and 1/3 VCC as required. So we can actually change the trigger and threshold points by applying a voltage to this control voltage pin here. These comparators, their outputs come over to this set reset flip-flop. It's a very, very basic flip-flop. And the reason that this flip-flop is required is because once its threshold is reached and it sets the flip-flop, well, then the discharge transistor here starts discharging whatever capacitor you're using for timing. So this threshold drops away almost immediately. So this is basically just used as a single bit memory to remember what the last state of the 5 was before either a threshold or a trigger changes that state. And of course you have this discharge transistor here to discharge your capacitor and an output section. And in the case of the genuine 555, it's driven from the same output of the flip-flop as the discharge transistor, so it goes through an inversion stage and then a power stage. But we're going to probably do something a little bit different. But before we go forward, let's have a short word from our sponsor, PCBWay. One of the really cool things about working with PCBWay is their complete clarity into the process that they have. So here's a board that I ordered yesterday, and I can go in and I can look at the production tracking on it. You can see every single step of the way. So these are all the main steps along the production line here. And if you have any questions about what each of these steps mean, you can go over here. You go to View Details, and it'll come up and it'll tell you exactly what each one of these steps is. Provides you information about the step, shows you what the step is like, and you can get further information about the process. Etching inner layers, drilling PCB, plating. It's quite phenomenal, the amount of information they share with you about what's going on with your boards. Once you start using PCBWay, your knowledge about PC boards is going to increase dramatically. It's basically 24 hours after the board is put in, it's then ready for shipping. So at this point now it's ready for delivery. And the next thing that will happen is the shipping department will send it off to me. Let's get back to our little project. Okay, so how are we going to do this? Well, it should be quite easy to do. Here's my take on it here. So we've got our voltage divider here. 5K resistors, unless you go to a specialty resistor, are pretty hard to come by. A standard resistor value would be 5.1K or 4.7K. I've got lots of 4.7K resistors, so we're going to use 4.7K resistors in this design. You could put in 5.1K. It doesn't matter. It really makes no difference whatsoever. We just want to get this 1/3, 2/3 of VCC. We also have coming down here a control, just like in the block diagram that we saw earlier. And here we have an LM358, which we're going to use as our two comparators. So that's it's got two op amps built into the one device. It's a very simple, cheap, and easy to come by device. and it makes a fairly decent comparator. So we're just going to use one of those. We have this side here set up for the negative trigger, going below 1/3 VCC. And we have this side here set up for the positive threshold, anything going above 2/3 VCC. And over here in this blue box, we've got our flip-flop. So we're going to implement that with a CD4001, which is a quad dual input NOR gate. The reason we're going to use a CD4000 series is because of the wide voltage range. So these are usually good up to about 16 volts, 15 anyway, and the LM358 is good up to that. So we should be able to get, from the 4 to 15 volts with this circuit here. And this is just set up as a very simple 2-gate set reset flip-flop. And these other 2 gates here, which are handily a part of the same package, are just used to allow me to put in a reset circuit here, an independent reset circuit. You don't often see it used, but just to give the same functionality as a 555, I've allowed for this here. Actually, to tell you the truth, I'm not even sure if that will work, but this I know will work. And for our output section here, we just got this push-pull arrangement here. I didn't put any short circuit protection in it, so we have to be careful not to short it out, but it should give us a couple of 100 milliamp source or sink before the transistors blow up. And then over here for our discharge transistor, our discharge element, I'm going to use a 2N7000. And the reason I'm using that is because I don't have to use a resistor here. I know a lot of folks out there are going to say, oh, you got to put a resistor on there, but no, you really don't. The impedance of these things is high enough. There's going to be no damage here. We don't need a resistor. Not at any frequencies that this thing is going to run at, just for testing purposes and having fun with this circuit. So that's it. That's how we're going to implement it. Very, very simple little circuit here. Just a voltage divider, an LM358, a CD4001, a couple of transistors, an NPN 2N3904 and a PNP 2N3906, and one little MOSFET at 2N7000, and a handful of resistors here and there. And that will give us our 555. And I've arranged things here, so that they match the pinout of the 555. We've got ground here, trigger, output and reset, VCC, discharge, threshold, and control. And that's precisely what a 555 will look like. So what did we come up with for a layout? Well, again, I wanted to kind of keep things kind of like the 555. So here it is. So we've got our VCC, our discharge. Let me get rid of that top layer there. VCC, discharge, threshold, and control. So they would be, pin numbers would go 1, 2, 3, 4, 5, 6, 7, 8. And the functions match what would be on a 555. There's our comparators. There's our voltage divider section. Here's our set reset flip-flop. Here's our output section and our reset. And this here is our discharge element. And I put in here a little tap into the ground here so we can put on scope probes to have a look around. And I wasn't able to get all the traces on one side like I normally strive to do. It took quite a while doing this, but there's no way I could get it all done. So what I did do is I tried to arrange things so that we get a really good distribution of power. So the top is going to distribute ground, and the bottom is going to distribute the positive voltage. So that's what I work for, to get a good, very low impedance distribution of power. I also threw in a handful of bypass capacitors just to keep things on the quiet. And so I'm going to send this off to PCBWay. In fact, they already have it. By the time you're viewing this, they already have it, and it's in manufacture. And when we get the boards in, we'll put this together. We'll have a look at some of the things you don't normally get to see when you play around with a 555. And we'll build up a couple of circuits. We'll try to test out all the functionality and see if it kind of meets expectations, see if it kind of behaves like a 555. I expect it will, because these are the same basic functions that are in the 555, and they're being used in the same way. Anyway, that's all I have for you today, folks. Just a short video introducing this little project. And well, we'll see you when the boards come back in. And in the meantime, we'll see you in our next video, whatever that might be. Bye-bye. Thanks for coming out.